Okay, on 22, what I would do in both of these is go through and clear fractions. Do you guys remember how to do that, or have you done that before? Okay. How you do that, look at equation 1, all of the numbers in your denominator, which are 2 and 5. What is 2 and 5's least common multiple? 10. So go through and you're going to multiply by 10 to clear those fractions. And you have to make sure you multiply everything in that equation by 10. So multiply by 10, multiply by 10, multiply by 10. All right, how you multiply that, the way I do it, I see how many times 2 will go into 10, which is what? 5, and then 5 times 1x is 5x. Do the same thing here. 5 will go into 10 how many times? 2, and then you have to multiply everything that's left together. So 2 times y times 2, that gives you 4y. Yeah, I know. I'll try to zoom in a little bit more so you guys can see that a little bit better. And then on this side, you're left with 20. Okay, at the bottom, tell me what you would multiply by for the second equation. 20. Multiply by 20. 4 and 5's least common multiple.
I'm in pain. I'm in pain.
4 will go into 25 times. So what are you left with here?
Whoa, oh yeah.
25x minus 4y, because 5 will cancel and go into 24 times, and then 4 times 1 times y, 4y, equals 140. Okay, so this is our system that we have now to work with. And the only work we've done so far is just changing them from fractions to integers. Yes, and that's, like when I was working this out the other day, I was like, oh, that's at least nice that it eliminates easily. And you don't have to do more work in that manner. When you add these together, like Carly Jo was saying, notice that your y's eliminate easily, and then you're left with what? You should have one equation in one variable. 30x equals 160. And this is the beautiful part, not really, but it is, we're going to say. When you divide by 30, it definitely does not come out to be a whole number. And reduce that. So what are you left with? Whenever you have pairs of zeros on the end, you can cancel those pairs of zeros off. So you're left with 16/3, or you could divide them both by 10. It's okay. It's been a while. Like, even though we've been in online school, like, it's still, I know, it's been. That's what I use my calculator. I can show you guys some cool tricks with your calculator too. If you, like, even the scientific or graphing ones, you definitely don't have to have a graphing one though. We won't use those, but Okay, so what do we do with 16/3? 16/3 you have to take and plug back in, and they want your answers in fractions in this problem. But would you want to take 16/3 and plug it in to one of your originals or one of these? All right, I would definitely plug it in to, I mean, you're still going to have to work with fractions, but I would plug it into one of these two equations here. So tell me, pick one. All right, let's do it. Yeah, smaller numbers. I'm all about that. So 5 times 16/3 plus 4y equals 20. I see so many mistakes with a whole number multiplied to a fraction. Tell me how you do that. You multiply the top, and then what would you actually be multiplying on the bottom? $16 times 5, of course, is 80. And then this is what most people want to do. They also want to multiply 5 to 3, and that's not right. There you go. Just leave 3. Okay, so we've got a few more steps to solve for y, and then we will be done. Subtract 80/3 from 20. If you find a common denominator between these two, tell me what 20 transforms to.
60/3.
Good. This will become 60/3. And then you're left with 4y equals -20/3. Are y'all okay so far? Okay. And then tell me what 2 steps you do to get y by itself. Okay, you can divide by 4 and take that one step. And then I've also got people that will multiply 3 to 4y and then divide by what? 12. But if you want to go ahead and divide by 4, that's the same thing as multiplying by what? So that would take care of all of your steps in one if you simply multiply both sides by 1/4. But you can do it however you want. So we're left with y. And then 4 will go into, like, do you guys cross cancel when you're multiplying fractions? Do y'all do that? Okay. You're like, no, yeah. You can either choose to multiply straight across and get -20/12, then reduce. But 4 and 20, 4 will go into 25 times, so you can do it that way also. But I'll just go ahead and multiply them straight across for you. Wow, where am I getting 60? -20/12. And then what will that reduce to? -5/3. And so remember to write your answer as an ordered pair. Yeah, it is a lot. Oh, just wait till the day. You're gonna love today then. Yeah, so I probably shouldn't have told you. Look at your notes already. I only gave you 7 problems for your homework for today's lesson, and then there's one at the very end that's easy, like it gives you the value of one variable, so you can just plug it into the other 2. But anyway, we'll talk about that later. All right, are y'all okay with this? Or do you understand it? You may not be okay with it. Or do you understand it? All right, let me go back to the top, and this is where you can actually begin your 3.3 notes for today. All right, there's really no set steps for solving systems with 3 equations and 3 variables. The best way I know to tell you, you pick, well, you definitely have to pick 2 equations, so that you do have to do that as step 1. Pick 2 equations to work with. You can use substitution, elimination, and some of these, you're going to see how in 2 equations, 1 variable, if you add those equations, will cancel. So most of the time, elimination is going to be your easiest route to go. So the extra work involved in this comes from starting with 3 equations, adding 2 of them together if you're using elimination. Then you wind up with 2 equations that have 2 variables, such as this. Then you go from there. So there's that extra step of getting a system like we did in the last lesson. And then, of course, you just work backwards to solve for other variables. What? I thought we were going to have to do that again. Oh, no. Okay, are y'all good? Have y'all got that right now? No? Okay. Okay, so you ready to begin? This is number 2 in your notes. Yes, in your notes that I posted. Yeah. And you don't have to write this last sentence unless you want to. When you solve a 3 equation, 3 variable system, your answer is what we call an ordered triple. Just like an ordered pair XY, well, now you have a third XYZ or ABC. Just make sure whatever variables you define that you put on in that order. Yes, there you go. Whatever, like if you find A is 5, that's going to be the first number you type in. And you're going to put it in parentheses. I think MathExcel gives you parentheses and then they give you 3 boxes to type in. Okay. So the first thing you want to do, see if there's any 2 equations you can add together and get a variable to cancel. So compare all of your A's. Well, I can't add any combination of those and A will cancel. And then look at your B's. Okay, so you can add which 2 to get B to cancel? You can add equation 1 to equation 2, so that's the route we're going to go. And another reason, your C's will not cancel easily either. But of course, you can, if you wanted to cancel A, you could multiply 1 through by a value. But if I see that variables cancel immediately, that's what I'm doing. So the first step, we're going to add 1 to 2. Can we go ahead and do that, or do you want me to write those 2 equations again to show you step by step? Can we just go ahead and do it? All right. So add equation 1 to 2, 3A plus A, 4A. And then, of course, your B's cancel, so C plus 2C. And then negative 15 plus 13 is going to give you negative 2. So we added equation 1 to equation 2, and that's what we got. Here's the part that you're really going to like. You have to either pick equation 1 and 3 or equation 2 and 3, and you have to manipulate those to get B to cancel, so that you will have a, to get B to cancel, because we want another equation that we can work with this one, and this one does not have B. But we can't pick 1 and 2 again because we already have. Okay, so pick another pair. And get the same variable to cancel. All right, so let's look at it. If I pick 1 and 3, you've got 3B and then negative 2B. But notice that if you pick 2 and 3, you've also got a 3 and a 2. So tell me what that needs to become in front of those. Like, tell me, do you want to pick 1 and 3 or 2 and 3? Because it really doesn't matter. All right, let's pick 1 and 3. So I'll say we chose 1 and 3. And we've got to get B eliminated. And I'm just going to write the equations down once again so you can see where they come from. You don't have to do this. So this is 1 and equation 3. Once again, what's my goal here? Good. We want to get B to cancel. They're already different signs, so that works out good. What do I multiply equation 1 by and equation 2 by? the number in front needs to be what? What can these both multiply to? They can both multiply to 6. So I'm going to multiply this top equation by 2, and I'm going to multiply the bottom equation by 3. Let's say, okay, go ahead and multiply that equation 1 by 2. You get 6a plus 6b plus 2c equals negative 30. When you multiply equation 3, you get 24a minus 6b plus 9c equals negative 54. Okay, so we're slowly making ground. It's a lot of work. A lot. All right, what do we do from this point? Add them together, and we wind up with 30a, b's cancel, plus 11c equals negative 84. So now we have this equation that just has a and c, and we have this equation that just has a and c. So that's the way you always want to start off. Try to get 2 equations that have 2 variables, and then now it's almost, well, it is just like we're going back to 3, 1, 3, 2.
The only different thing is we added another little equation.
Exactly. Yes.
Variable.
Yeah. Hey.
Hi, Miss
Hey.
Miss Coker. Oh my God. Congrats.
Thank you.
Anybody want to be Huntsville Fair this game tomorrow, allegedly? Unless it's canceled, but they're $8. You can still buy one. Yes. Size medium or large? Yes.
Another one?
Yeah. Extra large, we have.
We don't have a lot of fruit though. Extra large.
Okay.
How's it going?
It's going good. You miss me and Chase yelling?
Yes.
Of course you do.
Every day.
Oh my God.
Yeah. Yes. Oh, no. Hey, this summer, there's still things in that window.
Are you serious?
No, I'm not. Yeah.
You should just leave it there. It's never anything.
But I know.
Medium?
It definitely to remember you by. Make sure you tell Grace that her presents are still there. Yeah, enjoy. She totaled her car.
You should do some so that it doesn't look very good.
Oh, bless her heart.
Because it got supposed to be on a hot air balloon.
What?
A hot air balloon?
Yeah, he took me. He told me
Is he nice? Do you like him?
Yeah. I married him, so I guess so. But he
We'd approve.
what?
You think we'd approve if I were to do
Yes.
that? Okay.
He told me I needed to be up at like 4:30 in the morning on July 4th, which we went and looked at rings like a few weeks ahead. So I kind of knew something was coming, but then he said, you're going to think, where in the world are we going? He said, because we're looking for a truck stop and a white van. I was like, oh, okay. Not sketch at all. Yeah. I know, but it was beautiful. It was. Thank you. Bye.
Miss Coker, oh my God.
Love y'all. Y'all have a good day. Okay, now we have 2 equations that have a and c, so we have to work to solve this system. So this is not going to be fun either. I picked this one. This is one of your hardest problems that you have to do. Very or well, they're all a lot of work, but as far as the process to eliminate variables. If you want to get 4 and 30 to cancel, what'd y'all say?
I thought she was sick and I thought she was crying.
Look, that's what I was gonna say too. Be very careful with signs, because when I've worked these problems in the past, I would do the same thing. I mean, I would like page long work, miss the sign, and I was like, "Are you kidding me?" Just like rip up my paper. But okay, so I want to make a point here. 4 and 30, you would have to, like, their least common multiple would be 60. Yeah, 60, I think, off the top of my head. And then 3 and 11 is 33. So if I'm you, I would probably work with 3 and 11 just because they're a little bit smaller to deal with and then have smaller numbers. But okay, so what we're going to do is multiply. I'm going to multiply equation 1 by, you guys tell me, do you want to make 11 stay positive or negative to change the sign? Or do y'all want to change the sign of the second one? All right, let's do it. So I'm going to multiply the second one by what? -3. You'll be happy to know once we get past this unit, though, you don't see 3 equation variables anymore. Where? This? Sorry, that's an 11. I accidentally made a pin mark. This should be 11. Okay, let's make sure we multiply everything by 11. So that gives us 44a plus 33c equals -22. And then the second one, you get -90a plus 33. Whoa. See, there you go. We were just talking about signs. Minus 33c equals positive 220, 252. Four, 231. Yeah. Okay. Positive 252. Add those together. So for the love, we are finally able to solve for what variable? Your C's cancel. So you're, yeah, there you go. I know you had it in your mind. Oh, we're canceling C, canceling C. All right, 252. This gives us 230, and then -90 plus 44 is going to be -46. To what?
Yeah, I'm gonna have to use my calculator.
Yeah, that's
I
fine.
don't want to mess up.
That's fine. I'm not an anti calculator person. I mean, obviously.
Is it -5?
Yes, thank you so much. You just called me out on the -33 too a minute ago. Okay, -5. Whew. Okay. But it's a stroke to find one variable, but then once you find one, going backwards is going to be a whole lot easier. Yes.
Can't you just plug them all in now?
You can't. We just found A. We have to find B and C.
Oh.
Yeah. Look. No. All right. Let me go back. We had these two here that have only A and C. Well, we know A, so we could use either one of these to find C. But you can't plug into your original. Why? Because we know A, but what do we not know? Exactly. So if I plug A in, then I'm still going to have equation with B and C. So always, once you find your first variable's value, plug that one into one of your two variable equations. Does that make sense? Kind of. All right, so plug into one of the two variable equations. So I'm going to pick the 4a plus 3c equals -2 and plug a in. So 4 times -5 plus 3c equals -2. Okay, so that leaves you with 3c is equal to what? Good, 18. Well, because this makes -20 and then add it to -2. So 18. And then c is 6. Okay. Woohoo. Now B, last but not least, B. Can't leave it out. Can't leave it out. We have to solve for it. What? I know. I'm realizing that. Yeah. Maybe I should have given you. I think maybe I should have only given you like 4 or 3. Okay. Let's now. What you have to do after this is take A and C. Then this is where you plug into an original. Okay. So plug in.
No, we can now though, because you have.
Right. Yes. Take A and C. Plug into one of originals. Okay. I'm going to plug into that second one, which is A minus 3B plus 2C equals 13. Everything, most of it is positive. I don't know. You just pick whichever one. It doesn't matter. Okay, -5 minus 3B plus 2 times 6. Tell you what, would it help you if I post solutions to all 7 of your problems? No, they'll probably be different numbers, but they'll work similarly. I know, too bad you can't just look at solutions and type those answers in, huh?
Oh, it's not math Excel.
Yeah. You have -3B, and then when you add 12 and -5, that gives you 7. I'm going to subtract that from 13, 6. So B, I combined, I did a couple of steps in one. -5 plus 12 on this side gives you +7. And then, so that would be -3B plus 7, but then I subtract that 7. And then you get B is -2. Okay. Whew. And then you have to write it as an ordered triple. So A comes first, of course, then B was -2, and then C was 6. I told you guys you're gonna love this part.
This is gonna be the highlight of our year.
Okay, I would ask, are you guys okay? But yes, I've learned that quickly with you guys in 2 days, and you'll tell me how you feel, which I like.
At least we talked to you.
Exactly.
My B lunch class was silent the whole time. It was so awkward.
Yeah.
Like, hello?
Yeah, I've got an honors pre-cal class, and they're all really quiet. Only one of them. The other one talks to me, but and it just it's awkward. Like I'm sitting there trying to talk to them and have a conversation, and they're just like, Okay, well, guess what? It gets even more fun here. This is like number 7 in your Math Excel. This is your last problem in Math Excel. Oh, the last one.
I thought you said they give you a variable.
Oh, number 7 is a word problem. Number 6 is the one they actually give you a value and go through. Okay, so number 7 in Math Excel talks about a stadium and how many seats that are in the stadium. So the stadium has 52,000 seats. That's actually a very small stadium. 52,000 seats. That's what I probably need to put. It's split into 3 sections. So section A's seats equal the number of section B and C's amount put together. So they're telling you section A, the number of seats is equal to the number that B and C have added together. Then what else do you think they tell you about the seat? If you're going to a baseball game or a football game, what do you have to get in? Tickets. So they tell you that section A's tickets costs $28. B's, I'm gonna put ditto marks. Do y'all know what that is? It just means you bring that word down. B's tickets cost $16 and C's tickets cost $12. Okay, so one particular day, the stadium brings in a total of, we'll say has revenue of $1 million, I know, $98,400. You guys are gonna be glad to get out of the math class today, aren't you? Okay, so in a similar manner, when we talked about a word problem with the 2 variable to equation system last time, here they talk about 3 different things, and then they actually give you 3 bits of information about them. You know how many total seats are in the stadium. Then they give you another piece of information relating stadium A seats to B and C. Then they also tell you what each ticket costs. and a total that they brought in from selling out the stadium. So we're going to create 3 equations using that information. If we let A, B, and C, of course, represent those respective seats, then we've got A plus B plus C. What would that equal?
52,000.
Good. That would equal 52,000. We know that A plus B plus C should equal 52,000 seats total. So there's equation 1. And then we need another equation, or 2 more equations. So what's another equation you could write? Looking at maybe the second sentence. A, they told you that the amount of seats in A is equal to what? B plus C. And then finally, we need to write an equation relating their monetary value. So you've got the cost of ticket A times how many seats there are in section A, plus what? What would the rest of that look like? Good. Plus 16B, and then C, which I've already, C is worth $12. And then when the stadium is sold out, 1,098,400. Okay, this one is actually going to be better than that last one a little bit. Can anybody tell me why? You know that A is equal to B plus C. So if I take that and I plug into equation 1 for A and equation 2 for A, then I will have this equation that just has B and C, and I'll have this one that has B and C. And I can work with those. And I don't have to do, we don't have to do all that work that we did in the last problem to get to that point, if that makes sense. So we're going to use substitution in this case. So for equation 1, you're taking B plus C and plugging it in where A is. So that's what you're left with. I took B plus C, plugged it in here, and now I still have plus B plus C equals 52,000. They told you that A is this chunk. So you take chunk and plug it in place of A.
How's that gonna help us?
I'll show you. Tell me what that simplifies to when you combine like terms. 2B plus 2C equals 52,000. So this is the way it's going to help you. You've already got one equation that just has 2 variables, and that's your goal at first. 2 equations, 2 variables, and you already have one of them. I didn't have to multiply through. I didn't have to do anything. Second equation, you're going to take, of course, B plus C, and you're plugging it in here for A plus 16B plus 12C you have to do a little bit of work and then combine like terms. So you have to distribute 28. Okay, so combine like terms, then we'll have another equation that just has B and C. Are y'all okay so far? Do I need to slow down? Am I going too fast? Are y'all good?
Oh, I just have one question.
Sure.
At the beginning, how did you know?
Because it talks about three things, like if it, just like, well, I won't tell you that because that might confuse you more. This is the way you know. You've got three subjects, ticket A, ticket B, ticket C, or seats. Then they tell you how much the tickets cost for that seat, and then they tell you, of course, the total cost for that. So there's one. Then you know how many seats are in the stadium. So then there's the second piece of information. And then the third piece of information they give you is they tell you that seat A, how it relates to section B and C. So three things, and they tell you three pieces of information. So that's how you know it's a three variable, three system. Similar manner, if they give you two subjects and two pieces of information, then that would be a two variable, two equation. Does that make sense? Kinda. Okay, once you clean this up, you get 44B plus 40C Okay, so here's our second equation.
We only have to have two.
Right, in order to start solving for one variable, and then we can work back and solve for the others, yes. Okay, you don't have to rewrite them, but I'm going to just to show you what we are going to do with them. Okay, so this is the system that we're working with now. We have 2B plus 2C. You can't easily solve, well, okay, you actually can use substitution or elimination. I don't want to throw you off even more. I know your brain's already overloaded. But if you can notice in the first equation, you actually can go through and divide by what number? You could go through and divide by 2, then you would have B plus C equals 26,000. And then you could solve for one variable, plug it into the other equation. But most people are probably going to use elimination and multiply the top equation by something to get B or C to cancel. And that's what I did in your notes. Or well, when I worked it out earlier, that's what I did. I haven't posted it yet. Okay, what could you, if you want to get, tell me, do you want to get B or C to cancel? Which one do y'all want to do? All right, let's do C. This is a positive 40 here. I have to make this what? You have to make that negative 40. So I need to multiply through by negative 20. Okay, when we do that, yeah, negative 40B minus 40C equals what? Yeah, it is a big number.
What if like your equal sign?
Would-
The number after the equal.
Hang on, what'd you say?
What if like the
Oh.
number after the equal sign?
It winds up being the same. You could, well, I'll explain that to you in a minute. Like in this case, if both of those numbers wound up being the same, then you would just add those at this point. You would just add your two equations together and see where that leads you. Okay, so the C's are going to cancel. You're going to be left with 4B when you combine those. And then that negative, all right, this is going to give you 58,400. And then divide that by 4. And that's going to give you 14,600. Tell me how you would know if you messed up at this point. A stadium seat cannot be what?
Negative.
A stadium seat cannot be negative, and also it can't be a decimal or a fraction. You can't have half a seat. So that looks very normal. 14,600 is in section B. So that's section B's amount of seats. And then let's go back. Tell me what type of equation or which one you have to plug into now. Good. You found one variable, so you need to go back and plug in to one of the two variable equations that we found here or here. What? You can do it that way, but then you're still going to have some extra work because that would lead you where? That, if you know that A's seats is B plus C, so I mean, you could use some mental math and do that, like subtract the amount of B, the amount of seats B has, and do that. I'm going to plug in to this one. You can plug into this one also, but I know B, so I can work with this one or that one and find C. So plug in 2 times 14,600 plus 2C equals 52,000. Okay, next step, subtract 29,200 from 52,000, and what do you get? Do you know? All right, that gives you 22,800 and divide that by 2. So section C has 11,400 seats. Okay, tell me which equation we can plug into to solve for A very easily.
A equals B plus C.
A equals those two values added together. So just add the 14,600 plus 11,400. And that gives you 26,000 for section A. Okay. So I'm going to let you guys take a break and work on your 3.1. I mean 3.3. You can tell my brain's not functioning properly right now either.
Where is that? Yeah. Of all things.
Hey, you guys are troopers though. Like, I mean, this lesson really makes people ill sometimes. They're just like, "Ah." I mean, just give them like anger issues. What?